Welcome to the Advanced Upholstery Restoration Masterclass. Right now, we're taking your upholstery care protocols from basic, everyday cleaning habits and upgrading them to advanced, science-backed restoration systems. Whether you're a facility manager guarding expensive assets, a seasoned restoration pro, or an elite technician, this masterclass is going to hand you the exact, precise methodologies you need to execute flawless, zero-liability results. Let's dive in.
Our curriculum today leaves absolutely zero room for guesswork. We'll be moving progressively through 5 core modules: fabric science, advanced chemistry, moisture control, troubleshooting, and finally, professional execution.
Let's start right at the beginning with Module 1, the science of fabric. This is the absolute foundation of our entire masterclass, and it really comes down to one golden rule. Elite professionals always clean the fabric first and the stain second. You know, industry veterans often talk about the classic, expensive sofa disaster. Picture this: an untrained tech tries to get a simple coffee stain out of a luxury linen sofa. They hit it with hot water and an alkaline detergent. Sure, the stain might vanish, but all that excessive moisture on water-sensitive linen, it triggers severe fabric distortion, nasty water rings, and browning. The root problem wasn't the stain removal at all. It was completely misidentifying the fabric. By strictly adhering to professional technical guides, we stop these everyday cleaning jobs from turning into thousands of dollars in liability claims.
So, to prevent those exact disasters, you've got to decode the manufacturer's upholstery cleaning codes. These tags dictate the exact mechanical and chemical approach you're allowed to use. W means water-based cleaning is good to go. S means you are strictly using solvent-based cleaners. WS gives you a bit of flexibility with either water or solvent. But pay very close attention if you see an X. That means vacuum or dry brush only. If you apply water or solvents to an X-coated fabric, you are almost certainly going to cause irreversible damage to the fibers, the dyes, or the backing. It's just not worth the risk.
Now, even if you have that code memorized, you absolutely cannot skip the color fastness test. Think of this as your ultimate liability insurance policy. You need to test every single color with the exact products you're planning to use. Why? Well, applying alkaline chemicals to an unstable dye system creates dye bleed. And let me be completely clear on this. Dye bleed is permanent. Once it happens, there is no magic chemical remedy that can fix it. So, test first. Every single time.
All right, with our fabric safely secured, we are moving into Module 2, Advanced Stain Chemistry. This is where we focus on actually breaking molecular bonds.
Listen, our objective here isn't to just scrub aggressively until our arms fall off. It's to break the molecular bond between the contamination and the fiber itself. To really master stain removal, we have to zoom in to the molecular level. See, stains are visible to us purely because of something called a chromophore. A chromophore is just the specific portion of a molecule that actually determines its visible color. So our chemical strategy doesn't necessarily mean physically pulling the entire substance out. Often the goal is to chemically alter those chromophore molecules so that light just passes right through them. When we pull that off, this stain literally becomes colorless to the human eye.
To make that molecular magic happen, you have to master the chemical matrix of oxidizers and reducers. Oxidizers essentially work by adding oxygen to a molecule. They're incredibly effective at knocking out organic, natural stains. We're talking coffee, tea, natural plant dyes. Reducing agents are the exact opposite. They strip oxygen away. Reducers are your weapon of choice when you need to destroy synthetic, artificial colors, like dye transfers or fake food coloring.
Now, deploying these chemicals demands strict adherence to some core rules. You want to use enzyme digesters to break down proteins, like blood or food. For hydrophobic, oil-based stains like grease or makeup, you're bringing in the solvents. And here is a non-negotiable safety mandate. Never, ever mix oxidizers with reducers. Not only will they completely neutralize each other and ruin your treatment, but mixing them can actually create highly toxic vapors. Always ensure you have adequate ventilation and are wearing your proper PPE.
Stepping away from the chemistry for a second and looking at the physics, we arrive at Module 3, Moisture Control and Extraction. Why is moisture control so absolutely crucial? Because oversaturation is literally the greatest enemy of successful upholstery restoration. You really need to understand the functional difference between your tools here. True steam cleaning uses high-temperature dry vapor. We're talking upwards of 290 degrees Fahrenheit. It barely uses any actual moisture, it sanitizes beautifully, and it dries in a flash. Hot water extraction, on the other hand, actively sprays hot water and detergent deep into the fabric and then vacuums it back out. It gives you a phenomenal deep rinse,
but it leaves that fabric wet for hours. Guys, these are complementary tools, not interchangeable ones. You have to pick the right approach based strictly on the fabric's water tolerance.
And when you are running extraction equipment, precise pressure control is mandatory. You can't just blast every piece of furniture at 150 psi. For delicate materials, think silk blends, you've got to dial that pressure way down to the 45 to 65 psi range, otherwise you risk distorting the fibers. Your standard commercial fabrics can generally handle about 65 to 90 psi. It's really only for heavy-duty vinyl or thick canvas that you should ever crank that pressure up to the 150 to 250 psi mark. The golden rule? Always start low and only increase the pressure if it is absolutely necessary.
But look, even with flawless standard operating procedures and perfect pressure control, you are going to run into complex issues out in the field. Which brings us to Module 4, Troubleshooting Catastrophic Failures.
Here is one of the most notorious, hair-pulling complaints in the entire restoration industry. It's this mysterious brown or yellow discoloration that shows up hours or sometimes even days after you've finished the job. You walk away, leaving the sofa looking absolutely pristine, and the next morning the client is calling you in a total panic. So what exactly is causing this?
Well, this phenomenon is called cellulosic browning, and it is a 100% preventable chemical reaction. Natural cellulosic fibers, things like cotton, jute, or linen, contain a naturally occurring gum known as lignin. When you hit that with high pH alkaline detergents, you actually dissolve that lignin. And if the fabric dries too slowly, that dissolved brown lignin just wicks right up to the surface of the yarn tips through capillary action. To prevent it from happening in the first place, you need to stick to neutral or acidic pre-sprays, use acid rinses, and whatever you do, do not overwet the fabric.
But what if you're dealing with soil wicking? You know, where you remove a spot, but residual soils buried deep in the cushion migrate up during the drying process. The ultimate pro fix for this is actually incredibly simple but highly effective. Immediately after extraction, just cover the affected area with a damp, clean terry towel or absorbent powder and put some weight on it. What happens is, as the upholstery dries, that migrating residue will wick directly up into your terry towel instead of getting stranded on the tips of the yarn.
All right, to tie all of this high-density knowledge together, we're moving to our final module, professional execution. This framework is exactly what separates the elite, certified techs from the amateurs who are just out there guessing. Let's break down a standard operating procedure, or SOP, for handling a protein stain like blood or food. This takes absolute discipline. Step 1, get your safety PPE on, especially if you're dealing with a biohazard. Step 2, carefully remove any excess material with disposable towels so you don't spread it around. Step 3, flush the area with cold water, and I mean cold water. Using hot water will instantly cook and permanently set a protein stain. Finally, Step 4, apply a targeted enzyme digester to really break down those protein molecules and then extract.
And throughout this entire process, you've got to lean on your technical help guides for precise product dilution ratios. For example, if you're using an aggressive alkaline treatment to break down some heavy grease, your technical guide is going to mandate a specific acidic rinse right after. That step is crucial because it neutralizes the high pH, stabilizes the dyes, and protects the long-term structural integrity of that fabric. You can't just skip it.
Ultimately, your operational success out in the field relies entirely on adopting this systematic methodology. It means executing an accurate, uncompromising fabric inspection. It means meticulously pre-testing those dyes every time. It demands deploying the correct, targeted chemistry instead of just grabbing some one-size-fits-all detergent. It requires highly controlled moisture extraction. And finally, it demands rapid, assisted drying, using air movers to force that moisture out and prevent wicking or browning.
I'm going to leave you with one final commanding takeaway for your professional career. No issues doesn't mean safe, it means lucky. Look, relying on aggressive, high pH chemicals and excessive water might occasionally work out without destroying the piece, but that is not a business model. It's a gamble. Elite mastery is built on exact science, strict protocols, and real professional discipline. So I want you to ask yourself, look at your current operating procedures. Are you engineered for flawless predictability, or are you just relying on luck? Implement these frameworks and elevate your standard.